Modeling the shaft support. Hi, Joe Cerrone. Welcome to CAD 117, Intermediate AutoCAD. We're going to model this shaft support. The material is cast iron, and the measurements are in millimeters. I think the author should actually note that on the drawings, but we can tell that it's millimeters by these really big numbers compared to this other one next to it, which is in imperial units or in inches. So with that, let's get started. We're going to download the title block. And so I'm going to go to the title block section within AutoCAD, our course shell, and I'm going to download the B size. Let's go that from the beginning. So the title blocks are located under Content, and I'm going to go to the All Title Blocks, and I'm going to download our B size metric. And so I'll say Download and Open. So here's our metric template. I'm going to go to Model Space. I'm going to take a look at the drawing. And what we're going to do is we're going to start with the front view, looking at it from this direction. And so we're going to kind of create the outside perimeter, or the outside shape. And that's going to be 101.6 millimeters. And then the height's going to be a little bigger than 63.5. That just gets us to the center point. So switching back to CAD, we're going to go to the object layer. And we're going to start by drawing. Let's check our grid and our snap. I don't really think we need grid and snap at this point, and so I'm going to leave it off, but I am going to make sure that my polar setting is on. And so I'm going to go to Tools, Drafting Settings, and I'm going to go to Polar Tracking. I'm going to enable Polar Tracking. Snap and Grid I'm not going to use, but I am going to enable Polar Tracking, and I'm going to enable Object Snaps. I'll say OK. Let's turn off our grid. And we'll start with a line. And we'll just track that out to the right. And we'll make that 101.6. I'm going to just zoom and pan. And then I'm going to make that 63.5. And I'm going to track over this way, 101.6. And I'm going to type C for close. So that's the basic shape for that. And we're going to need to locate this center of this area here at 50.8 millimeters from the left edge. So to do that, we'll use the offset command, 50.8. Select the line and then the side. And then what we're going to do is we're going to draw the circular geometry. And these measurements, when they have this circle with the line through it, that means diameter. And so we'll make a 38.1 inch diameter and a 19. This should be okay, and a 19 inch diameter, 19 millimeter diameter, excuse me. All right. Circle, center diameter, right there. And we're going to start with the small one, which would be 19. Right click, repeat circle, locate it. I located it with an endpoint object snap. We'll say 38.1. And that is a radius. I can tell because if I hover over it, it's 38.1. And remember, it's supposed to be a diameter. So let's do that again. 38.1. Okay, now that we have the geometry, or at least the front view, and we've made it 101 by 61.3, we need to offset this bottom line, the thickness of the part. And it's going to be down this distance right here, 12.7, because this 63.5 was from this top edge. So we're going to make this a little bit bigger at 12.7 millimeters. So we'll say offset 12.7. And then we'll just bring these down with a grip. Hit escape to clear the grip. And then we're going to draw lines that are going to be tangent from here to here. So this is a little bit of the trick here. They're not coming from the quadrant, they're tangency points, so it'll be a smooth run out. So we'd say line, hold the shift key, right mouse click and say tangent. And then you can grab that. Now it won't do the tangent point, so I'm going to have to do the end point first. And so we'll go line from end point and then shift right mouse click and say tangent. And then hover around this circle and it'll find that tangency point. And we'll do the same thing for the other side. Hover, acquire the endpoint, shift right mouse click and say tangent. And then hit escape. Okay, we no longer need this line and this line. Actually we do, we kind of need the bottom part of it. So let's just go and pull those back down. This we can get rid of. All right. We're going to locate the other geometry here. We'll need the top view to figure out what that area is. And so we'll create this line in the top view. For right now, we're going to just go with the numbers that we have. And I think what we'll do is we'll construct the other views and then add some of the other elements. So we'll do the top view next. We'll draw the top view next. And it's 50.8 by 101.6. And so we'll box that in by projecting that line up. Projecting it over. And then projecting this line up. It's going to be 50.8. And it's going to be within boundaries of the front view. Trim, enter. We'll project, we'll fillet this front edge with a 19 millimeter radius, and then we'll create a 19 millimeter diameter of that whole feature. And then we'll figure out how to put this chamfered edge on there. Fillet, down arrow, radius 19, select the two edges, and then we'll make a center diameter at the center 19. We're going to offset the back 12.7 millimeters. That's this area right here. And then we're going to figure this geometry at a 45-degree angle. So we'll grab the line tool, bring it right here. And if we bring that at 0 or straight down, that's 270. And then as we swing this arc, that's 115-degree measurement. That's 2, that would be 30. That's 3, that would be 45. So it would be 225 degrees. And then we'll trim that. All right, the next thing that we're going to do is project up the geometry of the, it's called a boss. So we'll grab a line from, we'll project a line up from the quadrant here to here. Whoops. And from the quadrant here to here. And then this is 25.4 thick. So we'll offset the back. 25.4. And then we'll trim this. Hit enter after you run the trim command to make everything a cutting line. Be a little careful right here. All right. Next thing we're going to do is to switch over to the hidden line layer and project the whole geometry. And that's going to go all the way through. Now, it's really difficult to see the dashed lines here, so I'm going to update the LT scale by typing LT SCALE, and I'm going to change that to 24. And then I'm going to trim. I'm going to project up the center line. And as long as we have the center line active, let's put a center mark on the front view by going to Annotate, Center Mark, and then selecting the large outer edge of that circular geometry. And let's get this smaller one too. And then let's project down the hidden lines to that front view. And so you can see as you start to work these problems, what happens is that the geometry, and I almost grabbed the wrong part of it. I wanted the line from the quadrant, not from the endpoint. You can see it sticks out a little bit, just enough to make it inaccurate. Quadrant will grab the circular geometry. And then we'll project down the center line. So we're using these traditional drafting tools. We're actually drawing like we were drawing with a pencil using this type of a technique. And I like these center marks to be able to show that there's a long line, short space, short dash, space, long line. All right. So if we take a look at this, we've got the top view modeled and the front view modeled. There's a couple of projection lines that we'll need to project over a line on the object layer that maps back to here. Okay, so that's our front view, our top view, and then we'll do our right side view. And again, I'm going to make a miter line just from a standpoint of getting people to understand how it works. I'm just going to track this over. And then as I draw, I'll track this up. There's 15, 30, 45. And I just want it to go the length of the part. It can go a little bit farther if I track like this. And I'm almost getting my 45. There it is. It's the trifecta. And so then we'll go through and project over our side view. And if you can't track these, and I'm having trouble kind of tracking them, as you can see, just go ahead and just put them and extend them. So this would go from here. Let's do it the way I would do it with a pencil. So the way it would work would be to get the dimensions from the depth dimensions in the top view to the side view. What you would do is you would project them from this point here to this point here to here. And then we do that again with the back of the part. And then we can project over from the top view, from the top of the front view. And so that gives us the boundary, or at least the envelope for that part. And then we can just start to project over these other features. And so in the side view, we'll be looking at this from this angle. And so this is going to look like a rectangle, kind of like it does in this top view. So we'll project over the quadrants. Be careful not to get endpoint, because the endpoints stick out just enough to goof you up. We can project over this edge. And since we're doing this kind of in traditional orthographic projections, there are some quicker ways that I could do these geometries, but I just thought it would be good to show you how you would be creating those views by using orthographic projection techniques. All right, so we're going to just trim this. Trim. Enter. And we'll get rid of all that. We'll get rid of that, that. And then this needs to go. This is too far out. It should only project out this far. So we'll say from here, project to the projection line. And I'm not sure if I got the projection line because that went to midpoint. So I'm going to do that again. And then I'm going to go down. And I'll trim. I'll project over the hidden lines from the quadrants. I'll trim. If you're having trouble acquiring the endpoints or the quadrants, make sure that your OSNAP settings have those enabled. So they have this little check mark on it when it's enabled. All right, let's switch over to a center line layer. Grab a line. I'm going to go back to my object line. The base doesn't look right without the base. There we go. Let's get rid of these. There we go. And I guess this line could stay here. All right, we need to locate the hidden hole feature. And to do that, what we'll do is we'll project it off of this view on the hidden line layer from the quadrants to this point, and then down. And again, quadrant. Trim. Get our center line. Clean this up a little bit. I think it looks better without that line there. We can talk about that a little bit as far as how lines are projected and such. All right. So we've got our right side view. Our front view has a few extra things that need to be cleaned up. All right. We'll add the dimensions to that and switch over to the dimension line layer. And we'll use the linear dimension. And I can see that the title block has like microscopic text, which means that my text height or my dim scale needs to be increased. So we're going to try first with the dim scale. To do that, we'll go to the Annotate tab, and here's our dimension scale setting. It's our dimension style. So I'm going to modify the default by changing on the Fit tab the overall scale to 25.4. And I'll say OK, close it. Terrific. So that increased the size of that text proportionately, and that's what we want to be able to do. Be able to have that at the correct height. We'll put the other dimensions on here. We'll go with this automatic dimension maker. We'll just grab here and here. Unfortunately, it's not smart enough to know I wanted a vertical dimension there, so I won't be able to do that. I'll have to use linear. Linear used to be called horizontal and vertical, and then somebody figured that it's only one click difference. So here's our 63.5. We can put our diameter dimensions on here. We can put our side view dimensions. I'm just going to stick with my linear dimensioning. Put our angular dimension. Put our hole size dimension. Holes are always going to be in diameter. And again, when it double dimensions that, double center marks it, you can click on it right click, go to properties, and turn off the center mark. And then we can add some of those other dimensions here. We wouldn't see this part of the line, and it might be a little tricky as far as to knowing how this works. So I'm going to trim this out like that. And then we'll put the dimension like that. And I usually put an overall dimension. I would have done this like that. All right, there might be a dimension or two that I don't have on here. I'm going to remove the reference plane line, or maybe we'll just change it to some color that's really not very obvious, like yellow. I think we'll remove it because we'll put a 3D version there. And then we'll center this on the title block. We'll go to the ANSIB, double click in the viewport, and then we're going to bring this up. Like that. We're going to lock the viewport. Double click outside of it. This will be lab 3C. Place your name on it. We're going to leave this one set up as fit for right now because the scale is a little bit kind of, it's not exactly being able to let us set it at full scale. And so we're going to leave that at fit for this point. We'll save the drawing. Save it as your initials. I believe it's 3C. And this will be the 2D version of it. So that completes this exercise.